Hello, my name is Sarah Priscilla, and this is my Physics 2211 Lab 5 Choose Your Own Adventure, The Fallen Slinky. Introduction. The objective here is to compare the motion of a slinky dropped from rest with that of a computational model of the same object with the presence of drag. This will be used to show that the bottom of a stretched out slinky will not move when released. The models used and why. One, computational models are used from glow script. The computational model has object dropped with the presence of drag. The model is then compared to an experimental model made in Tracker. The fundamental principle here is Newton's second law, which states that force is equal to mass times acceleration. The kinematics user equations shown below, which is the force equation, graph force, and then the velocity and position update formulas. So here is the preview of the outcome. The comparisons between the experimental and computation models will show that the slinky does stay still, or like the bottom does stay still for initially. The initial conditions show a slinky at rest with no velocity or acceleration. The gravitational force is consistent as gravity and mass are consistent, but drag force increases until it equals the gravitational force. The system is a slinky, and the surroundings are the air, resistance, and gravity. Here are the track results, which shows manual tracking over here, and then the graph in the y direction. So there are a few discrepancies as the data was manually tracked by hand, so human error is present. Additionally, on the tracker data, you can see that plotted points are not completely accurate and external factors were not considered. Here's the glow script code for the computational model for gravity and drag. Here you can see ball end mass is 0.204 kgs. Position velocity was about 0, as the bottom of the slinky was considered to be the initial position. And time is starting at 0, and delta t is 1 divided by 30. Gravity is 9.8. The j hat is 0, 1, 0, and then b is set to be 102, which is the constant for drag force. And here is code continued for computational model, which shows when the tension force, which is the force above from the top of the slinky, and then the gravitational force are equal to each other, which results in no movement. And this is when the forces are changed, so that the slinky starts moving down when the top and bottom get closer to each other. So here are the results, which show that this is the results from the experimental model, and this is from the computational model, which show they are fairly similar, with this line being somewhat jaggedy because this is all done by this is all because of human error and possible discrepancies, as some factors were not considered in the experiment. So now what does that mean? The results show that the experimental and computational model computational data is similar, which means that the slinky's bottom will not move initially after the top is let go. Thank you for watching.